Hello, this is Phil Thomas, New Era Systems. I'm going to do a couple things today. I'm looking at a small, it says that it's a 2-watt buck made by Gillette. Most likely that it's not. It's more likely to be an NJT buck of some sort. But anyway, we'll get to that in a moment. I want to talk about 10 megahertz reference and 24 volt power supplies. These bucks, particularly the small ones, they all require power to come in through the IF cable. The small bucks, 24 volt, the larger bucks, perhaps a 10 watt, 20 watt, could expect the power to be 48 volts, also coming in over the IF cable. When you get to bucks even bigger than that, they have their own AC power, and so it's not necessary for the modem to produce either 24 or 48 volts. Consequently, some modems that our customers have do not have the option for the DC power supply. And then when they plug in the small bucks, like this one for example, they won't work. And they won't work without 24 volts or 48 volts, and that's as simple as that. So what we've done, just for ourselves, we've made a little power supply. Well, it's not that little, it's a full rack unit power supply. But it's a 24 volt DC power supply with a 10 megahertz reference built in. Now, why did we do this? Because we have a lot of modems with 24 volts and 10 meg reference, but I just wanted to have this on the shelf in case. Here's just a few of our CDM 570L modems. The bottom 4 all have 24 volt, 10 meg reference. The top one, curiously, is a 625. It's a more expensive modem, but when it was purchased from the factory, it didn't have a buck power supply. Probably because the original owner was going to power something like 100 watt or 200 watts buck, and certainly they don't need a 24 volt buck power supply. So we made this very unspectacular looking box, and this is what we're going to use today instead of one of the modems. And we're going to use this frequency generator to generate, in this particular case, I've got it set to 1200 megahertz. As we're looking at a KU buck, that's going to be 14 gig output. So the other components in the system, a dummy load, a cross-guide coupler, and that's the power head for an Agilent power meter. The power meter has been set up to expect 14 gig, and it's also set up to compensate for the attenuation on the cross-guide coupler. At 14 gig, the attenuation is 39.88 dB, and that's what I've set onto the power meter. So now any output that I get from the power meter will be accurate and already calibrated to show the correct output from the buck. So we've got a couple of things here. Is this really a 2-watt buck? Is it a 3-watt buck? So let's go ahead and I'll get the thing going, and we'll start stepping through some of this and see what results. So now the setup is complete, it's about time to begin the test. I'm going to turn on the RF on the frequency generator. Because it's at such a low level, there is very little to be seen in the way of output on the power meter. Now I'm going to increase the power on the frequency generator and watch as the power increases on the power meter. We're still in the milliwatt range. We haven't even made it to 1 watt yet. I'm gradually coming up. Okay, we're up at 1.8 watts. So now I'm just going to move up a little cautiously, because if this is a 2-watt buck, I don't want to push too much into it. So I'm just increasing gradually now. I'm increasing in 0.1 dBm steps. And as I do that, you can see the increase coming along at a pretty linear rate. Okay, 19.07, 1.42 on the watt meter. It's moved up to 1.6. 1.7, again, it's still linear. 1.78, 1.8. If it's really a 2-watt buck, we should be getting towards the saturation point on these things, but it's still moving up quite easily. I'm beginning to think that it was mislabeled, and in fact it's a 3-watt buck. Even though when they state the power of any any amplifier, it's an approximate. I mean, one 2-watt buck could produce 2.5, even as high as 3 watts. It's really a typical figure. But anyway, we're up now to a comfortable 2.6. I'm increasing at 0.1 dB, and it's still showing an increase in watts. It's gone up to 3 watts now. I could go up in larger step sizes and make this a little shorter, but okay, that's it. We're there. It's just over 3 watts, so I'm going to call this a 3-watt buck. So again, let's just recap. I'm not using a modem to generate the 24-volt DC or the 10 megahertz reference. I'm using this home-built box that, if anyone really needs it, we can certainly supply these and more. They don't look very beautiful, but they work pretty well. The frequency is coming from the Agilent frequency generator, so that's the only thing that's, that I'm using that for. And the output is being monitored on the Agilent power meter. So this seems to be quite successful. This supposed 2-watt buck has topped out at 3.05 watts. Seems to be extremely healthy, and it was very linear all the way up to 3 watts. So I would be very confident in labeling it and selling it as a 3-watt KU band buck with frequency range 14.0 to 14.5 gig. Okay, wrapping up now.